their electronegativity, how available their lone pairs are, and whether they can join resonance or hydrogen bond determine how reactive oxygen, nitrogen, and sulfur are in organic molecules. Think of each atom like a player in a game. Electronegativity is how much the player wants electrons, so oxygen often pulls electrons harder than nitrogen or sulfur. That changes how likely they are to give or take electrons. Lone pair availability means whether the electrons are tucked away or ready to use. So if a lone pair is tied up by being part of a bond or involved in resonance, it cannot act as a strong nucleophile or base. Resonance spreads electrons over several atoms, which can calm down reactivity because the lone pair is shared, and hydrogen bonding can either stabilize an atom or make it less likely to react depending on the situation. All these factors together decide whether a heteroatom will attack another molecule, accept a proton, or stay put. Students often think that higher electronegativity always means stronger nucleophilicity, but that is not true, because more electronegative atoms hold onto their electrons more tightly and can be less nucleophilic in polar solvents. Remember to consider solvent and steric effects. Another common mistake is ignoring resonance. A lone pair that participates in resonance is less available for reaction, so don't assume a lone pair is always reactive just because it exists. Finally, people sometimes forget that sulfur is larger and more polarizable, so it can be a better nucleophile than oxygen in some reactions, even though sulfur is less electronegative. Think about size and polarizability, as well as electronegativity. For more videos and resources on how heteroatoms behave in organic reactions, check out our website www.gumballdegree.com.